Hey, what's up, Ziguanas? Good morning if you're in Europe, or good afternoon, good night, I don't know where you are in the world. I'm doing this stream a bit in unusual time for me. So I used to stream only nights in Europe, but because today I have a very busy day, I had to do this either this morning or postpone it for a few days, and I wanted to finish this an inline game today. So this is a special edition of the 30 Days of Z Coding Challenge. Special because I will do a practical coding exercise to practice what I've learned so far in 26 days so far learning Zig. My journey. My name is Dusan. Welcome to Zignited. So like I said, I'm going to continue. I mentioned this yesterday when I started N-Line. So this is basically this game that I started coding yesterday. And I'm kind of halfway through finishing it. And I did almost 2 hours stream yesterday coding this game in Zig without UI, just the logic. For now, maybe in the future I will add some UI in one way or the other. And I spent literally 2 hours coding this game, and it's not finished. So that's why I'm having this second stream at this moment. And I'm even reusing some code. So without reusing the code, it would take who knows how many hours to write everything from scratch. And I am taking this code, which is in one of the previous streams I went through this code. This is the Roberts improvement of my first 3 parts of streaming coding tic-tac-toe game. So this was the first thing that I coded, that I practiced, was a tic-tac-toe game. And then I streamed for 3 days, and then Robert suggested some nice things to practice to learn more about Zig language. So this is what Robert built on top of my code, and now I'm kind of like reusing Robert's code. So it's very, very hybrid code, what I'm doing now with the N-Line. So I'm creating, like I said, a version of this game, which is in the original, it's called Connect 4, is the most common name that it is known by. And it is also known with it has different names. One of the names is 4-in-line, and I'm doing N-in-a-line because I want this to, because it's a software, right? The original game is a plastic game, physical game, and it is 7 columns and 6 rows, and you have to connect 4 in a line, like diagonals or rows or columns. And now I'm making a Zig version of it, which is of course then scalable because it's digital, it's not physical. And I have the code that you can use to customize the number of rows and columns, and also customize the sequence that marks the winning situation. And I did that yesterday. So I still haven't published this code to GitHub, but I will. Once I finish today, I will put the final version of it to GitHub. And this is what I was saying. So I did set up here the defaults to 6 and 7, like in the original game, and also 4. The sequence of 4 is for a winning situation, like in the original, but of course I will test this also for different sizes and different values. So what I did yesterday, where I stopped, I created these comp time checks so that the game is set up in such a way that it is playable, that it is not. So for example, it would make sense that you have the board 1 by 1 or even 2 by 2, maybe it's too small. So that's why I have this. This is just like for fun and for learning Zig. And still I use the hard-coded values of turns. So this is like where the player wants to play. So in every turn, a player can choose one of the columns to put a piece in, and then the piece will fall all the way down. So I still haven't implemented this insertion into a board. I just print the board how it is, and currently it's an empty one, so it doesn't have any pieces inside. So this is what I've done so far. I've just made a code that will visually display a board. As here, I think I've run it, yes. So can I scroll this higher? No, I can just do it in this way. And I don't print the board. Yeah, I print it here. So this is the visual representation. Why it's like this? Because here there is a sequence of 3 characters as a string literal, and the third one is representing the empty place in the board. And then I just left this from tic-tac-toe game, it's X and O. So X and O will represent the red and yellow pieces from the original game. Of course, you can change it, doesn't matter. So at this point, it works in this way that it displays the board, and I've disabled some loops here, so it has also the game loop, but I've disabled it because I tested some things yesterday. So I will turn this on today again. And yeah, you can watch the first video, like who hasn't watched yet, you can, probably it's a better idea to watch the first video than this one. And I added also this history, just again to play and to learn Zig. So the point of this history here, this array, is to record the history, so that maybe in the future when I add the user interface that and maybe some button like undo and redo, so that you can kind of replay the games. And I overcomplicated a bit because I wanted to practice putting structs into arrays. So technically I could have done it in this way, because the only thing you need is to know where the player played because of the gravity thing, so you know exactly where it will go. So you don't need X and Y coordinates, you just need one number for each of the players. But I wanted to practice, like I said, making structs for a history, and again, redundant information, so I can easily extract the information from these, so I can know who was the player, where. So this is the only thing that I need. And the turn, I can also literally count, and I will know which was the turn. But I just wanted to make this in such way that I practice it a little bit more. That's the main idea, right? And that's pretty much it, what I have so far. So the most important thing I did yesterday was this part, when I generated when I set this to be a 2-dimensional array, because I haven't done it before. This is the first time I'm creating multi-dimensional array, and this like syntax was very tricky for me to figure out. That was interesting part. And afterwards playing with this, like setting the field into a struct that is inside of the array. So because of this, again, the syntax and the way what you have to mark as constant, what you have to mark as variable. So this is still something that I'm at the very beginning of understanding that part. And yeah, that's pretty much it, what I have done so far. So today I will try to finish in this stream. Let me see the chat. Hi, Robert. How are you? Yeah, that's a surprise early stream. Yeah, because I will not make it today. I would make it to stream this one plus the regular one. So I'll just do the regular day 27, I believe, this night, European time night. And that's why I had to do this earlier. Okay, so let's code. Let me see what is the next thing that I could do. Let me see the state of the code currently. So this is the main for loop, where I just print for now the turn. This was to test, so I don't need to do this anymore. And definitely this thing I will delete. This was just for test to see if I'm setting these structs inside of an array in a correct way, because this was something that I struggled with yesterday. So now this works. I don't need this anymore. And then I don't need this to break anymore. This was just to protect from invalid index out of bounds error, because here I don't have enough moves for all the possible number of moves, the maximum number of moves, let's say like that, because if the board is 6 by 7 like it is now, so it's 42 possible places if there is no tie, so then it can be 42 turns at the most. But in this case this is lesser than 42, and because I was generating these indices dynamically, and I wanted to print all of them, but not in these moves, in the other array that is about history, then I just didn't want to go outside of the array. So that's why I did that break. That was a quick fix just to test things. And about these moves, so they are not correct. They cannot contain any numbers that are greater than the number of columns. So depending how we want to say where we want to play, how we want to enumerate the columns. So I can say the first column is, so this one on the left. So let's click on one of these images that we have some large. Let's see this one. It's not that large. Anyways, so let's say this first column, it can be number 1, this can be number 2, 3, 4, and 5, or I can say this is 0, 1, 2, 3, and 4. So maybe I'll use the human numbers and say 1, 2, 3, 4, 5 in this case. So in this case, the largest number cannot be, when you select the column, cannot be larger than 5. So this I will add later into also here, maybe into pre-compile time check just for fun. But in the version of the game, when I introduce the interaction with the user, that will be dynamic, of course. So now I will just change this so that we have no columns like this. So I will just, let's say 2, 1, 3, 4, 7, that's okay. So 9, 8 we don't have, let's say 4 instead here. Let's make 2, let's make this 4. Let's make this, I just want to have some valid moves for now. Oops. And of course, you can have more than 6 in this case in one column, but I don't believe that I have. So, and I will check this later anyways. So this is just to have some number of regular moves to play with. So these moves are now regular. Then let's see what I can do here to check in the main function. So I printed a turn, then I have the board, the history. Here also this has to go because this was just to test things, and this was just to select the field. So I will comment this out. This is going to be the actual move that I will do. I'll just want to run this and see if this runs now, if I haven't messed up something by accident now by deleting things. Yeah, it works fine. And now we have these turns. So I don't have the draw board because it would be too many. 42 times it would print now. So this is enough for now. Now what I want to do is I want to actually take the user input, so the moves, so like what we had here. So if I scroll down here, this is the checking part, but in the main loop. So after determining the current player and saying which is the turn, which I have here at this moment. So that's this part. So the next thing was to do this, to see what is the last move. So this was from the tic-tac-toe. And here the idea it was to see what's the last move. And then let me just remember what was happening here. Just to go through the moves and then to take a specific value from it and then to actually play. So we can do this. I will just adapt it for this version because now it's a bit different. So this is not the same. It's not one-dimensional array anymore. It's two-dimensional arrays. And this is also useful. So I will copy and I can then even draw the board. Let's do that. Yeah. So here I will paste the same thing. And last move, did I make that variable here? Where it was defined in the original. Here. So I don't think I have it here in the main now. Yeah, I don't have it. So let's just define it. Oops. Let's do the same. So this one is taking 0 as a use size. So this will be the index of the move, right? And then this is taking, yeah, I remember this. This is playing with the range of the type. So what it says here. Okay, then let me see what happens here now when I have this last move. So the for loop, last move plus, okay, this is with the, how it's called, wrapping addition, with something like that. I forgot what the official name for it, how it's called. And then it generates the moves from 1 to the moves length. Okay, that's the same. Then names it a move, so it goes to the move, and then we check here now in a different way. So it's not if board moves move, but it will be a little bit different because of the gravity thing and because of the two-dimensional array thing. Let me see what you guys wrote. Robert says, you know, you can hide from native setup forever. Yeah, I cannot, definitely. Let me open up Paint here. I want to explain what I'm about to do. So we have this situation that we have. I'll just make it shorter, a smaller board just to make a point. It doesn't matter. So these are the column numbers. And I will have just like some potential things that can happen here. Like this. So if the player chooses now to play, so this is now all turns. Turn of the player O, doesn't matter. So if the player chooses to play here, then it should be the first row. So I enumerated these rows like this. This is the index 0, 1, and 2. And these are the indices 0, 1, 2, and 3. So these are the human numbers, these are the indices. So if I choose to play here, I should have 0, 0. Those are the, so let's actually write it here. 0, 0 are the coordinates for this field. If I actually choose 2, then it will be 1, 1, right? This is now by the accent, it is going to be, everything is the same. But imagine that we have here O and then X here. So now if I choose 3, then the coordinates will be 2. So the row, sorry, not 2, 0. That's the number, the index of the row. And then 2 is the column index. So this is how it should be done. So from here, what we can conclude that it's probably the best idea to just go from this index. So the index of the column is fixed. This is what's the choice. But I don't know in which row I will put the piece. That's the dynamic part. So this part is fixed. We don't change it. But this one we have to play with. So I always have to try. I think this is the easiest way to do it. So I always try to find the largest row index and see if it's empty. So in this case, it's not empty. So it's false that it's empty. So I then move on to the previous one, which is in this case index 1. Again, not empty. There is something there. So false that it's empty. And then I go one more time. I decrease the index one more time. And in this case, for the first time, this is true. And I have my field. I know where to place this. So this is the logic. This is what I should test. So I fix the coordinate for the columns, but I should iterate through rows and find the first one that is empty. And if I reach the top of the column, then I should say something like, okay, you cannot play there. This is already full. Something like that. Of course, in this case, it's going to be, we still don't have these. Even in this version, there was not something like advanced handling with some special cases, but we can make it something like a core concept that just the game works. And then next time, when I introduce the human players and not read the actual sequence here, then we can do such things to optimize even more. Okay, so that being said, let's do here the code. Let's see what we have to do. So the move in this matter represents the index of the not the index, because I said I'm going to use these are the human numbers, but of course the index of the move is an index, right? So let's see, let's go back here, let's see what we do. So for loop, we loop, we take the last move and add 1 to it, and then 2 and 3 and so on. So we take the move, we generate the move in this way, the index actually, right? So we then take the moves with that index, and then we try to see if it symbols 2 here in this case. Why symbols 2? Because symbols 2 is the underscore, so the mark of the empty field. So in this case I cannot do it in this way. So instead of this, I will copy paste, oops, did not want to do that. I will copy paste this entire if condition and comment out this part. And in this condition, I have to ask if let's first do the multidimensional thing. So instead of saying the move, so this is going to be our column number, column index. So, or actually number, yeah, because I set the human values there. And this is going to be dynamic. So this one I have to change. I have to loop one more time and to go through all of the indices for the rows. So this is the first one and the last one. So I basically have to start here from, I believe, 6 rows. So 5 is the largest index in this case. So what I need to do, I have to start with number 5 here. And then if this is full, then I try 4. If it's full, then I try 3 and so on. So which means I need one more loop here. So let's create a loop here, 4. And then let's do, we can do even while here, because I literally need an index to generate. So I can say while. And then here I can say, let's create I here. So let var I be equal to 0. No, actually I want to do the 5 thing. So that will be the row minus 1 in dynamic way. So let's start this I, or let's say Ri, row index, that it's clear what it is. So I say while row index is greater than or equal to the 0. Then I want to do this entire thing here. That would be one way of doing it. Okay. And I can do here how it was, I think, columns, and then here the syntax where I can say I minus equals 1. So that it decreases the I by 1 automatically. And not I, sorry, Ri. I called it Ri, not I. So then I can do here Ri. And I say if board for this row index with this moves move index, but in this case move is generated here from 1, right? So let me see what you said here. No, you didn't mention anything about number 1. How did this? Because you had 1. Okay, yeah, because you start with the last move and you set the last move first to be 0, right? Where it is. I'm blind. Yes, it's starting from 0. That's why it starts here from 1. Okay, because it has the default value. So this is correct. And let me see. The next thing would be, so this we check if the row with this index and that specific move is equal to the empty one, then we update that here. So that board, why didn't I copy the entire thing? Okay, so now board on that place is equal to the current player, and we do have current player, right? Yes, it's set up here. So this is then taking the value of the current player and assigning it to the board. This should be okay. And then break move, because this is also, I remember why we did this, because this is we were playing with the moves that could be illegal. That's why this is set in this way, so that you proceed to the next turn only once you try the correct move. Okay, so then else error. Okay, this is the same. This can be fine. So let's try to see how this works, because I'm looping inside here, inside of the while. So theoretically, I will try the entire column, and here I will need one else if I reach, or I can just let it go to the next one to try to do the next move. So I just don't set it. So in this case, it's not dangerous. Let's see how this will work. And I will also draw now the board so that I can see what is happening under the hood. And let's run and see if I have some errors. Let's see what Robert wrote in the first iteration. Last move plus modulus 1 equals 0. Row. This is something that I wrote in row, how it's called? Rows. Rows, not row. Just to see. And let's see what Robert. So in first iteration, last move plus equals, so let me see. Where is it here? Last move plus %1 equals 0. If that helps, that is why I have the overflow there, because I need to start from 0, while I want to keep the addition there, since I don't want to start at the last made move. Yeah, makes sense. What is it now? Okay, this is the casting problem. So this expression is, so this one here, because I didn't have the type, it is going to be of this type, must be const or comp time. Okay, so let's do number of rows. This is the comp time known, -1. So I think I can just set this to different type. So I can set the type for this to be, let's do U8. This should be fine. I mean, if we are not going to have more than 255 moves. And let's see what they say. Error value of type usize ignored. Which one is now usize? So the problem is in the while now. So while ri is greater than 0, ri minus equals 1. Value of usize type ignored. And which one is usize? That doesn't help. Okay. No, actually, no. Give me just a second to think. Rows -1. See what you wrote. For indices, you should use usize. You of course don't have to, but it's nice to do, especially since you expect to have generic input. Okay, so let's then do usize here, and let's see if this is going to fix the problem. What did it say? Ignored. So there is something else here. Let's see what you wrote. The problem is the break move. It returns. So this Robert says problem is the break. It returns a value from the current scope loop. Okay, yeah, it's not labeled. Yeah, because I added additional. Okay. So I break this while, and I used to break this for. Yes, it's good. So this is like why it's good to have someone who is experienced in the language to help out, because in this case compiler would probably mislead me a lot, because I would focus on what it says here, a value of type use size and then while, and then I wouldn't understand that this is for because of the break. But yes, it makes sense because it used to break this for loop, and now because I added a nested loop inside of this for, I'm actually breaking this one. So then I have some options that I can do. I can either, when I break this one, assign the move here and then break again from here, or I can directly break, which is probably better, from this for here. And in that case, but I will have the problem if I do that. If I break only here from the while, then this last move, when it reaches the end, will not assign the value to this one, right? So that will be a problem. So I have to cover all the cases. For that, let me see what Robert writes. It returns for current scope. It was for, that is correct. Now the closest loop is while. Yeah. Compiler is telling you that since the while is returning, you are ignoring the return value of the while, which is why it complains. Thanks for clearing that up. So what I want to do is I want to take this move and break it out of this for. And because I have assignment here, can I just add the label here? That would be, so if I call this one, let's say F loop, just as a label like this, and can I break, in this case, break F loop with, I forgot the syntax, if it's like this, or let's try. And I don't know if I can do this at the first place. Expected semicolon after statement break for, okay. So I forgot what's the syntax. Let me see here. The break, where is it? It's the columns before, in front. Okay, so here, let's try like this. Flip. What is it now? Okay. For loop is expression also. Wait. Error value of type use size ignored. The for loop is expression also notice the overflow addition. Yeah, so it's not happy with what I've done. So here I just want to see what is different. So here they have the label in front of the code block. Here I have the same, but it's a bit different because this is just the block, it's not a for loop. And for here they break the initial value, the init initial value. So this is completely different situation. Let me see if they have another break example, but with the for loop. If it's possible to do it in the first place. So this is breaking the block, breaking the block, breaking the block, breaking the switch. How many of them are 75? So I'll try to find the for loop here. Maybe it's easier if they have some example here. So they have the sum here. And where is the block? Yeah, here they have the block. Yeah, so it looks like you cannot do that in the way I want to do it. Let me see what you write. Since for is returning, you're ignoring. Okay, I remember labels like this, opening the label with the name and using it as name. The columns needs to touch. Okay, you have break example with for loop in your here my code. You have break example with the for loop. So let me see here. So last move equals 4. Then this is the code block for the for, but I cannot do break this move. So I can maybe delegate this if I do break move out of here and then say something like here last move equals while, and then I just take that out of for, like a chain reaction maybe. That's easier to do. Let's try do that. So let's say this here. And then I just break. And actually, do I break or... Yeah, just break move, right? So this is to return. And then here, I can just break if... Yeah, but then this is not going to be helpful at all. Let me see what you guys wrote. The problem is because you are naming the inner scope. So I have to then somehow take this into the code block. Yeah, this is like very weird for me because I'm not used to these kind of things. Well, in my day-to-day in Python, you don't do things like this. Let's try to then say, let me just have this visually to help myself. How they break outer, so they, so they just put it in front of the, yeah, I was blind, it was literally here. Yeah, this is so weird that you can, I mean, in my mind it's weird, I'm sure it's completely fine, but in my mind, I'm familiar with this kind of thing in front of the code block. Yeah, okay, so then let's do, switch back to this, and then do this in that way. So here, let's see if that makes sense. They break outer, and I just want to see if this will work with assignment. So they have only this part, but I need to do this and treat the for loop as something that provides the value. So let's see if this is going to work. Yeah, this is why we practice, to learn these fun things. Did it run already, or I didn't click? Yeah, it did run. Expected after statement were 9514. 9514 here. Let's see, because yeah, this is me changing, so I don't need this here. So then, because it's assignment, it needed that. Okay, now it doesn't anymore. not enough. We ran out of moves. Split type void found error. Now we have some. We ran out of moves. Okay. This is because we are in the main and we are doing this and we are having this error. So I don't need to do this now. I will just comment it out. So for this, else I will just set this to something. So then the last move, what I can do here, or I can just return. I don't have to say return like this. And then I will return from the main. Maybe not in the nicest way. But for now, just as a quick fix so that we can move on. Yeah, okay. Because this is going to be fixed in the real use case scenario, real scenario. There is some problem here. What does it say? Index out of bounds. Index 7. Yeah, because I'm using the human numbers. Okay. Yeah, because moves are indices. So I will put this back, or I can do -1, but I'll just put this back and make them human numbers. So let's say this is going to be 0. That's a quick fix. Yeah, it looks like it's now implementing the gravity in a correct way. So I still have to see what will happen if I reach the top, if it will just go to the next move, because it will not be valid, or it will do some damage. But this is fine. So far, like this populating the board works fine. Let's just like trace it from the first time it tries to fill in. So this is the 5th, this is the 6th, and then in the 7th one. So after the 6, they put the 2 again, which is 0, 1, 2. It's correct. Yeah, so it looks like it's filling in just fine. Interesting. And I just want to test now. Let me see first which route, Robert. Sorry. The problem is because you're naming it inner 4 scope, yes, but you want to break the 4 itself. The thing you did is possible, but then the 4 does not return actually because you're at different scope. Yeah, that was the case. Then you can do both, but your way doesn't not return from the 4 itself. You named the wrong scope. From my experience, you can break from outer loop in Python directly. No, you can, but I was saying the problem is not about not the problem. What I meant to say is not that you cannot break from the outer scope. Yes, you can, but I meant this way how you mark, like when you do this thing. Let me go back here. When you label things, where it is here. So I'm used to doing this like here in Python, but in Python you don't have code blocks. So it's pretty straightforward when you think about how you mark things. You don't have an option to mark it here and here. And in some other programming languages, for example in Java, I'm used to, maybe they changed Java and I don't remember, so I worked with Java last time as a developer maybe 5 years ago. And I worked with on my job with very, so it was already like version 17, 18 was out and we used 7. Because it was a legacy code. But in Java, I remember that you could label the code block, and then you can select like that the outer scope block that you want to break. But you cannot do that, or at least I don't remember that it was possible to do this in Java, that you can also mark something that is not a code block here. So from what I remember, it wasn't possible. So this is what the part that confused me, because Z kinda can do both. That's what I meant. this, like where, so the syntax is for me is the biggest problem. Like here I was struggling with the syntax, so I knew in my mind what I want to do, so that I want to break the outer scope. When I realized what was happening, I wanted to break the outer scope for like 10 minutes. I didn't know how. And the same thing that I had the problems with here is the syntax. So I know in my mind what I want to do, like I want to have a multi-dimensional array, but I didn't have clue how to arrange these things so that I do that with this expression. Of course, this is not the only way you can do it, but I wanted to do it using this this approach with the 2 stars operator, just for practice and to learn this syntax, the Zig way of telling it what you want to do. That's what I meant. Let me see what else you wrote. Read the error, it tells you how to fix. Yeah, so thanks. Sorry, I didn't see when you were writing. In the note message of compiler error, they are useful most of the time. In the note, okay, thanks for the heads up for the next time. Okay, now I just want to test what happens if I fill in one column completely. So let's add, so I can have the same number of moves. I will just add 2, 2, and 2 at the end. That's the easy way of doing it. 2, 2, 2. Now let's see what will happen when I breach the number of rows. Here, this is the last valid, right? So this is the valid, this is also valid, but then the next one, we have an error. What does it say? Integer overflow. Why this happens if I say while r is greater than I equal? Okay, for the equal part. Okay. My mistake. My mistake. Where is that? Here. Yeah, this is the order, like when this is going to happen. I'm not used to this in Zig yet, like to understand when something happens like this. Let's see now. Now we don't have the 0 part. Wait, what is happening here? Turn 16. So now it doesn't apply one number here, so it has to have equal part. But why this breaks when this condition is checked? So I do want to include 0, so I do need this to be equal to 0. But the problem is here that this will decrease, I think one time after I do this. So maybe I can break it here. Probably not the best idea. And then I can just break the flop. Yeah, but that's a conditional break here. So maybe it's a very bad design, but just to test if this will work, at least for now. So if the Ri is equal to 0, and so how can I know at this stage if it was filled in this? Yeah, this is the order problem. So because when it does this here, so it can do it if it's empty. So if this is the case, right? So here I know it's empty, so only then it will fill it in. And then, so I don't need this one here. So this is not the problem that I have when it's when it was empty and it was filled. I actually have it here. So if Ri is equal to 0 and we reach this point here, then I don't want this to happen ever again. And if I understood correctly, this is after the while cycle is finished, this is going to happen at the end here. So that's why when it's 0, it's going to try to do one more time. Maybe I'm wrong, but let's see. This is the way to test. So if this is the case, then I just want to break this loop without returning to outside of here, just the while loop. Let's see how this will work now. Okay, this is now the, yeah, so this is valid. This is the last valid state, and then it breaks. Okay, now it's correct. Let's just test if after this potential move, let's say, because it's not going to actually do anything here, it shouldn't. If the next one is somewhere where there is space, if it will work, just to test. So let's say here, if I do any other number, so let's say 1, doesn't matter. If it will work still, just to test the logic. So it was here, it was O and X, and now there is X. Yeah, so it does work. Okay, so it seems to be fine. Probably I will see, maybe I have another bug if I go all the way and there is a tie. Maybe there will be something that will break the code, but we will see that in the future. So now it looks like, I'm not sure, but it looks like the logic for making moves is correct. Now we just need to implement the winning situation. So what we had here, to check for a winner. So I will do the same here. And I think I don't have that function here. And I think actually, I didn't see the math you did, Robert, for this version, because I didn't want to spend any more time on that live stream and jumping into the math part, but I will check it now. So it might even work already, like out of the box. We'll see. I mean the calculation, so not the we had a single dimensional array, now we have 2-dimensional, but I mean like this math about like a row minus, you know, like the offset, making an offset to calculate things. Maybe that will work out of the box. I will see now. If not, I will adapt it, no problem. But just I'm curious about it. So here, then this check for the winner. If check winner board, so we pass the board, and then the moves, last moves, or last move, sorry. Then print the winner is character current player. And then break, and this breaks the main loop. Okay, and then maybe I will have to draw this before so that we see it. It makes sense. Or I forgot if we are already drawing, but it doesn't matter. This is easy to change. So check for winner. I think I didn't copy that function. Yeah. So let's do the check for winner, the huge one. Yeah, it ends here. It starts here. So imagine that I write everything from scratch. Like it would take, it's already, how long is this stream? It's already almost 1 hour. So yesterday, 2 hours almost. So almost 3 hours. And I'm still not finished. So imagine if I did everything from scratch. So we want this draw board. Okay, so I'll paste it here. Let me see what you guys wrote. Robert says, yes, syntax is a bit harder. It's not crazy, but still much harder than something like Python. Yeah, I mean, it's lower level. Of course, you have to tell many more things explicitly. Python will conclude on its own. Doesn't matter. It's going to be. It doesn't mean it's going to be a good decision, but it will assume things. Hi there, welcome. Man, this stream is so early. Yeah. Yes, already hour in. Yeah, I mentioned before I did it. So I started so early today because I'll have a lot of things to do during the day, and I was afraid that I will not be able to make this stream and the regular day 27. I think today in the evening, so that it would be too many hours back to back, so that I was afraid that I'm going to then postpone this stream where I will finish the end in line. So I was like thinking, should I postpone this for a few days and then finish it in a few days? But then I was thinking, okay, in a few days it's going to be over. Literally like 30 days of coding challenge will be finished, and then I wanted to do something next, like the next project, so I didn't want to postpone that one. And then I said like, okay, I will do this one early, so probably people will not see it, but you could at least find it later as a video after the stream is live. But it's good that you made it. Yeah. Then Robert says you can reuse the math. It literally uses the row and column already. Yeah, yes, I was guessing it's the case because I haven't analyzed the code, but I kind of remember flashing it in front of my eyes, like the length, the r minus, wow, all these like math that look like it's adaptable and it's reusable for something like this. So the only thing that probably I will have to change, not probably, but for sure, is here I'll have to change this into 2 dimensions. So this is one coordinate, and I will need another one. Let's see. So maybe I will have to split it into 2. I will see how you did it. Let's see what else you wrote. Robert says hi to Dev. Yeah. Then Dev says, lol. So when is the native setup stream? Well, I believe on Sunday, because I'm literally running out of things to do. So already at the end of docs. Then Dev says, yeah, I read this. Then Robert says he's escaping. I'm escaping it hard, yeah. Trying not to install Zig locally. Yeah. Okay, let's see now this winning check winner function. So it receives the pointer to board and change it, use size, and this is the last move. Okay, then let's see what's happening inside. Change the row. So now the last move, it's a little bit different because we have the last move. What I return is just the number of the column, and we don't have any idea what is the row, but I can change that. So I believe it's going to be easier if I return here instead the last move being one number that says what is the column. I can make it into a tuple or something like that, so that it's X and Y, so both the column and the row, so that then it can be reused there. Maybe that would be a nice idea. So then let's see how, actually let me just double check something. Yeah, the movie is index. I keep forgetting if the movie is the index or it's the actual thing. So the number of the column in this case, what it was, but actually it's an index, which means we need another index, which means I can say, so I can change this into last call, for example, and last row, just to have 2 variables, and then I will put them inside of the tuple. For example, that can be an anonymous tuple just to play with, so that I don't introduce another struct. I already play with structs up there, so just to play this, like make a tuple dynamically out of 2 variables. So here I can say last call, and I will do the same thing for the last row. I see the problem with this. Wait, just to be sure, last move is used here. Yeah, so this is going to be a bit different. Okay, I will not change the last move. I will just rename it to last call. I will not add here this part. I will rename it to last call so that it kind of hints what it is. Then here last call, because I changed the name. Then here again. Move, slide, move, so I have to be careful. just to double check if it's somewhere else. I'm not seeing anywhere else. Yeah, no. So this breaks the move, which becomes a last call. Okay. So now I would actually like to pass the, not here, sorry, here. So, this is the move. Okay. So this is the last call now, called last call. So basically, this is the last call. It is a move. Okay. But let me see if I can change that a bit, because I need the row anyways. So let's say here. So this is giving you the column. Right. And then we will be missing the row. Yeah, now it's a bit different. So now this is actually not necessary because we will have the column, and the rows I have to send in as well. So how it's the row called here? How will I know? So here I will know. If I'm here, it means that I made the move. So I then return the move, which in this case is just the index of the move. But I have to, so I will lose information. If I don't want to do again the loop there to understand the change, I will have to here return the row and the column, not only the row, not only the column, sorry. So here I need to return RI as well, and I need to return the column. So basically move this thing. This is the column. This is what I want to return together as one thing. And then I can use this as something different. So I will keep this as it is to generate all these things that I don't now completely change the structure. But I will just create one more variable. Let me undo the changes first of all. That this is now called last move again. Yeah, okay, now it's fine. Now I will paste back this part here. So then the last move, let it be what it is. I just want to return here, not the move, but actually I want to return more things. I need to return the row index, and I need to return, yeah, this is trickier because this for loop depends on the last move, which is the index. So I have to leave it as it is for that reason. But on the other hand, I need to have the information about the row. So I will have to somehow merge them together. Maybe I say this last move plus this is okay. But I want to do, so this expression I can leave for sure. But here I don't have to actually accept this as the last move. I can make these two variables and this struct. So let me see if I can do that, the deconstructing, how it's called. So if I can say last move, so if I say RI, not RI, but I will call it a row, comma last move equals this. So let's try to do that. And that here I return a tuple and then deconstruct it immediately. Let's do, this is also nice practice. So let's do that. And I have to create a variable for this row. So here it's called var row index. Or wait, if I just use this RI when it breaks, it should be the last valid. So if it breaks from here, then from here. So yeah, this last move, yeah, but it's in the inner scope. So it's defined here, and it's in the inner scope. But I can make it outside. Let me try doing this. So if I do it here, and then here I just reset it to the same thing. So if I do this here, every time I am in this for loop for every cycle, then it should be fine that I should still have this RI having the last known value, so that I don't even need to return. Okay, let's try this and see here before I run the function. Let's do a test. So let's see here something, just something that is going to be extremely visible. And let's do here this, and let's do something in between like this. And what I want to pass is RI and the last move, just to see how that will look like. Okay, and let's run the code. Okay, 5 1 5 2 5 3 5 4 5 5 4 6 4 7 4 8. Let's see if this is correct. So 5 0. And I have to be careful where the board is printed. So this is before the board, right? Yeah, so it's literally in front of the board. So 5 0. Let's see. 5, it looks correct. 0, it's not correct. Ah, the last, this is the, yeah, sorry, this is the last move. It's not what I want. I want this. This is the index of the column. Let's see now. Board, this is the first one. Then here 5 2. Let's see. I have to scroll a bit. So 2 is the correct index. Then the next one, 5 1. Yes, it's correct. Yeah, it looks like this is correct. So now we extracted the information. Let's go just like the last two, just to double check in this case. So in this case, it's 3 1. And let me see where it put the, yeah, so it was here, it was empty, and here now there is something. So 3 0 1 2 3, it's correct. 1, yeah, it's correct. And in this case it was here, right? So 0 2 0, the first row, 2, yeah, so it looks like it's correct. So now I can pass this into the checker function. Let me see what you guys wrote. I did it yesterday on company Linux server. Needed to compile something with the native flags. It took yeah, trolling me about the installation. Took like 2 minutes. Most of it me looking up how to uncompress it. Yeah. Last move is an index to moves. Yeah, I keep like in my mind. I'm like, I have the attention span like a goldfish. So 1 second it's there and it's gone. It's an index to moves, not the real move made, so you don't need to return the values. You can look them up in the moves. Yeah, also there is nothing blocking you from moving the victory logic to the next move for loop, except, yeah, that's also true. The need to label the game loop so you can break it. Yeah. Interesting concept. Sorry, I didn't see the time when you wrote. I was too focused in this. Let's see. Now I can use these to check for the winner. And I want to change this. So I want to pass the row index and this, not only this, which means I have to change Oops, went too far. Here. So this is going to change. I'm going to take the first one to be the row index, and the second one will be now the column. What am I doing? Row index, and this one is going to be the column index. You call them change row, so I can just name them that way. Changed row. So this is the changed call, just to be consistent. We don't need these. And then let's see the next one. Let me see what you wrote. Rename it. Then I'm starting to regret of naming. Okay, then let's do row index and call index. Can I do multiple? How can I do this in this ID? Probably I cannot. Doesn't matter. So let's do it the hard way. Column, and the row. Let me see. Column. Oh, this is going to be a lot of changes. Let's do one by one. So let's try first horizontals to check. So to win, check, call index, check, call index, to win, call, check, to win, offset board, change at. This is changed at, which is, now I don't have this anymore. Yeah, so it's a little bit different. Wait, I will have to be careful because it's not only the names, but it's also here because it's a different structure now. You have to be careful. So I will leave it. It's easier just to have it as change row, and then at the end I might, if I remember, to change, but it doesn't matter. So this is now not necessary, but I will just leave it to understand what you referred here to. Okay, so let's go to the logic better. It was meant for the last move. Thanks. Okay, so 4-0 to win. Okay. And what is to win? To win is up there. Yeah, I already forgot how it's called. Okay, so check the capture group called check. Change column. If it's greater than the check, that's okay. And change column. I'm just trying to see the names, and then I'll think about the logic. So change column plus to win, less than calls plus check. And calls we don't have anymore. No, we have, yes, that's the global one plus check. Then 4-0 to win, offset board, change. So this is going to be different. Okay, let's then see the logic. So this part is fine, it has everything. Let's just see the logic. So if the change column is greater than the check, and the check is 0, 1, 2, 3, 4, right? So it is going to repeat, in this case, 4 times because we set to win to be 4. So it is going to check if the change column is greater than the check, which is 0, 1, 2, 3, 4. So it will do this dynamically. Then change end, end, change column plus to win lesser than. So this it looks like it's correct still in this design. Lesser than calls plus check. Yeah, so this is correct, should be correct. Then let's see the for loop. For another for loop, for 0 to win, then you take it as an offset. So this is now just to create an offset, okay? And this is horizontal. I have to keep in mind that this is horizontal check. So it will go +1, right, along the row. So if board, and now this is going to be different here, but then not equal place tile. So it checks if all the pieces in this row that are these 4, not the entire row, but this section of the 4 being checked at this moment. So basically, and this is only 4, but let's say we have 7 like we have, so then it considers this 4, and then it will consider this 4, and so on. So it checks first of all if they're not equal to not to empty field. So then it proceeds to the next stage and continue horizontal, and that means that there is a winner, right? So this is continuing to the next one if it's not place title. And here they say if changed at, so change at is what I don't have, but this is what it was. So in the original, the change at was the name. Let me just double check, I forgot. Close it. Wait, GitHub, where it was here, I copied it from the GitHub. Yeah, this one. And let's do check how the function looked like. Change at was what was sent here as the moves last move. So the index of the colon. Okay. So then this is changed colon. Okay. So then let's think one more time. So if change colon plus the offset minus check, and check, I forgot what was check. Check was from here. Okay, minus check not equal playstyle. Okay, so it seems to be correct still in this design. Then continue horizontal. Here, if it's finished, it says found horizontal, right? Then returns true in this stage. So pretty much it should work for the others. I just have to be careful that I change the things that need to be changed. So changed row, that's correct. Check change row. So I will not even try to analyze this math, because if it works for one, it's logical to assume that all the others are correct in this design. Of course, I will have to do changing this part here, that it matches the two-dimensional array, not one. But I first want to change the names, that I don't forget where I'm focusing, what I'm focusing on. So here, this is the same. Change row, check, change row, two win rows, check, change at. So this is the only change, I think. It's just calling this changed colon. Check calls, offset calls, playstyle, yeah. Then here changed call. Right, it was, no, not there. Wait, what did I do? Change at, I have to be careful. Change at, I have to change. So check, change row, check, change row, two win rows, check, and change colon, check, change colon. Okay, change row, change colon, playstyle. We don't have at here. Then here, yeah, because this diagonal, right? So it's a bit different. And this is another diagonal, so it should be symmetrical, but the opposite of the previous one. So two win change row, check, change row, two win rows, plus check and change colon, plus check, two win changed call. Yeah, we don't have changed at, so I don't have to change. Okay, so the names are now correct. Now I have to focus on the two-dimensional part aspect of it. Let's see what will. Yeah. So I'm not. I was just like trying to figure out the logic. I will have to adapt, of course, for the second dimension, but I just wanted to check the math part, not the coding part. Let's say like that. So of course, this is just like one index, and I need two in this case. but it will apply, the same rules will apply. So this will still apply, but actually this part will still apply. This I have to change into, so I have to have something like this. I have to say, have the 2 coordinates, of course. And this is about, because we are going to the row, so the row will be the same. So which means I should be able to do literally this here, fix the row because it is the same in the horizontal. And I can just say what is the index of the row. It's called changed row, right? So this is changed row. And here I do the changed call. Okay, plus the offset. So it's going to try to find first the very same one, then the next one, then the next one, and so on, minus check. And check is what is generated here, right? So I keep forgetting that there is another loop. So this for to win. So it tries to generate number from 0 to 1. Sorry, from 0 to 3 in this case. And then here we generate again the same numbers, but this is for the offset. So in this case, the check starts from 0, right? And also the offset starts from 0. And they are both used here. And then, let me see what you said, sorry. And change call not equal change at, you can see the relation between them in the first lines of the function where they are calculated. Yeah, maybe it will be faster if I just do it from scratch. So not that this is correct for one dimensional, but maybe it will be simply faster if I do it from scratch for the 2 dimensions, just to not spend a lot of time trying to adapt this. Let me see what you wrote. My bad, I understood your intent wrongly. Thought you were done with it. No, I was trying to keep as much code as possible and to reuse it, and then just like to go through pieces first and then to extend it to the second dimension. So I can use a lot of it, but maybe it's easier if I, let me actually do one more thing here, just to visualize these things. It's going to be easier. And once I do one, it's going to be easier. Where is my code now? So I will copy it there because I don't want to switch screens all the time. And I will just copy this part. Yeah, I need just this part. I don't need the entire thing. So here, let's do this as a text. Oh, this is so nice. Okay, and then let's make it in the corner. And let's do some example here. And I will draw this as 1, 2, 3, 4, 5, 6. Let's do one more that it's like the real one. And I will focus just in the first row, so I don't need all of them. Well, let's say, it doesn't matter, first, second row, the same. So let's say we start the loop from 0 to win. So we are generating, so the check is starting with 0 and it goes to 4. And then we have the first question, if change colon. And let's say the change colon was now at this point, let's say this one here. So I have to have some dummy data just to have something. So let's do here. Let's assume it's like this, and that we have somewhere else some O's, doesn't matter, but this is the important part, that we're trying to test this part here. So, and let's say this is the last, just to start with this one. So this is the last move here. So then it says if changed colon, which is in this case 0, greater than equal, then check and then check. So it is, right? So it is 0, 0. And change colon plus to win, lesser than colons plus check. So change colon plus to win is 4, right? And this is lesser than calls plus check. So calls plus 0, it's correct. So this is just like sanity check. Yes, we should proceed inside to do this offset. So this is basically just to test if this part is not like here, like not here. This is still correct, but let's say like here, starting here, then it would be wrong and it will be outside of the screen. So that's why that check. Then the second one is creating 4 more numbers, 0, 1, 2, and 3. This is the offset because you're testing from this one. Okay. Then we say this is an offset. Then the test is, so this is now 1-dimensional. No, I actually changed it. This is 2-dimensional. So change row is the same because it is the same row. And then we check if the change column plus offset minus check. So change column is 0, offset 0, minus check 0. So check is, I can ignore this part for now because it's still the same at this iteration. So just the offset is what is important here. So it tests if this is not equal place tile. Then continue to horizontal. Then horizontal is this one, right? So it's the main for loop. So it then goes to the next one here, which is the 1. So then it will test this one in the same way because we have the situation that this is true. It's not equal the placed, not equal placed tile. So I was thinking it was empty. Okay, this is a different logic. In my mind I was seeing it for some reason that it's like not equal empty. So if it's not equal the placed tile, you just skip to the next one because that means that cannot be that's the opponent's piece. That's the point. So if this is true, this means it's opponent's turn and you don't need to check there. Okay, makes sense. Then you just continue to the next one. And then if it's equal, so basically this means not equal to the place tile. And where do we check if it's equal to empty? We did at the compile time in that case. Or no, wait, when did we check that it's not equal? Let me just see the original code. I forgot how it works here. How it's called. First of all, this was called symbols, right? Symbols, yes. So let me see. So from 0 to win check. Okay. This we went through. This we went through. So it just checks if it's not equal the placed tile. Where is the check for symbols? Let's see what they do. What is it done with symbols? So this is the current player. So okay, this is check for if it's empty, symbols 2, then the move is there. I don't see any check for the empty field in the dynamic way. How come? So it only checks if it's not equal the place tile. Yeah, on the play style. How come this runs? Let me see what you guys say. It looks correctly, by the way. You will need to test it, but at first look seems correct. Hey yo, hey Lior, how are you? Long time no see. What's the weather like in Thailand? Check winner does not care about symbols we're using. It just looks at whether there is to win number of the same symbol in a line. What comes in is not relevant. And what happens if you have like 4 underscores, for example? How does it know it's not the winning situation? Because here you have you use this as the last tile, so you only call for the last, and the last is already checked that you actually placed something there. So you place the move, you make the move, then you say so you pass where you played, and then here change that, becomes here placed tile, board change that, so that you know what is the last move. So you're basically only searching for the current one. Okay, now I understand. Yeah, makes sense. Okay, so it just searches. It skips if it's not the last move, the symbol of the current player, let's say like that. So whatever the player, whoever plays now, this will be that player symbol, and this not equals will literally mean doesn't matter if it's empty or is the opponent, it will not be considered a winning situation if you have this in place. Okay, so then let me see what you wrote. It does the smart thing and does not check the whole board, only the positions that are possible for the last place tile. Yeah, I understood now. And since that is never empty, you don't have to check. Yeah, and it's understood that this is the last player's character. Okay, nice. So then we have this check here. So if we go all the way through this and then we don't continue here, it means that there was practically matching four lines, because we check if this is, so what you're actually saying here, like it's literally like if this is the winner's symbol, if this is the winner's, if this is the winner. So if you pass to this, it means you found the winner and then you return true. Yeah, okay, makes sense. And let's see here in this example. So we know here if we pass here that we have a winning situation. Otherwise, it will check for the next one. So this parent, like the outside for loop, will move on to the next element. In this case, 1, right? It used to be 1, and then you have starting from here, and you're checking these for here. Okay, nice. So then it will work if I fix the row here, and then the change column. So I believe this is going to work for the row. And let's test that. Let's make a win situation. So here, if I do, so I can even leave, sorry, I'm looking at the wrong code. So I can even leave the code as it is. I'll just comment out just in case, not to think about potential code breaking features that I might have left here, because I was focusing on one here. So let's test if horizontal works now. So I have 2 dimensions here, and then I want to test the moves, how they look now. I just want to see first if we have, no, we don't have a winning situation. So let's create one. Let's make this, I will keep these because this is a nice example for making all these, testing all the columns, and if you can reach the end of it. And now I want to make a winning situation. So let's say 1, then this is, let's say 1, this one will just copy. It's the easiest thing I can do. 3, 3, and then 4. So this is just not to start with the first one. I cannot start with 0. And this basically doesn't matter because it should detect winner here already. Actually here for the X. And let's run. Let's see if this is going to work. What they say? Change at where? 66. Wait. Okay, place tile. So this is not board change at, it's board changed row, changed column. Now, oops, now it's different, of course. Okay. Yeah, it works. Nice. So this part is detecting the winner. Let's try to detect, I know it's going to work, but just like sanity check. So here I can do just this. So then player X place in the first one, then player O place in the second, then the first one here. Because I'm not detecting the horizontal, I can just force X to play in the same row, and this guy, so just to not mistake, yeah, this is X. 1, 2, 3, 4. This is okay. So now the O should win, although of course X will have 4 in line first, but in the column, and we don't check column yet. So that's why it should detect O winning. Yeah, perfect. Now let's do the column. So it shouldn't be that different to change the winning situation. Here, the vertical part. Okay, so this part the same. This should be correct. And now this is to calculate the offset for the y-axis, right? Which, sorry, for the, yeah, it's the y-axis is the row. So which means that I should theoretically, without analyzing the math, be in the best case scenario able to do this here, that I just use the changed row, change call here directly, because now the column doesn't change, but the row does. So let's see if this is going to now detect the X as a winner. Something is wrong. What does it say? It's overflow immediately here because it goes down. It tries to go down. Let's see. So change column. In this case, let's say 0. Right, no, the next one should be here. The next player played here. Well, I don't know if it breaks, where it breaks after the first move. Yeah, so then it's here when after the player X played. So then the change column is 0. So I'll copy paste just to have an easier time analyzing this manually. So this here, I mean, I don't even have to comment out, I'm not going to run it. This is 0. Then the check for the first one is 0, right? So 0 times, so this is going to be 0 no matter what, because it's 0. Offset at the beginning is 0, so then this entire thing is going to be 0. So it takes the first 0 minus 0 plus 0, if I'm not mistaken. And then this is just for the first iteration, of course. Then in this case, it's trying to find the top left corner, right? This is 0. And place tile is going to be, okay, place tile, and here change column is going to be 0. So this is 0, 0 in the first one. Then in the next one, let me see what you guys wrote. Sorry. Lear says all good. Yeah, nice, nice. Enjoying Island. Robert says change row plus offset minus check should do the trick. Changed row plus offset minus check. Changed row. Aha, yeah, because now it's different. We had larger numbers. Okay, so let me copy paste. I'll trust you on this one to save some time. Yep, did the trick. The winner is X, perfect. Now we should test the diagonal, right? So the diagonal, this is the first one. And let me first create the condition for this to be, and which one is this one? Top left, bottom right. Okay, top left, bottom right. So let's do first some sequence of, so this is going to be a bit not trickier but longer to write. So 0 0 0 0, so that we have XO XO. So then the O is the one that I'm trying to win, right? So then we can have I will just do the last one just to avoid X being next to X so that it doesn't win. So the last one is 6 here. Then I will start 2 2 2, right? So then it will make the third row here. Then in the next line, so wait, I have to be careful. This is XO XO. Now X plays, so X can play here 3 3, then the O, and then finally X can play, for example, 6 again, and O can play. No, this is the 3. Wait, I skipped 1. Yeah, 1 1 1 1 1. So let me double check. So this is for making 3 in the second column. Then here 2 2, easy to save, right? So X plays first, then O, then wait. So here I have XO XO, then OXO, then it can be XO. Yes, that's correct. So 2 2, and then I can have this as a 6 and then 3. So let's see. Oh, no, I don't want to run. I have to code the diagonal. Let's see what you guys wrote. In diagonals, you can easily see the columns and rows part of the index calculation. Let me see. Where is the code? First of all, here. Diagonal 1. Okay. So, yeah, this is the... I can literally do this as 1 and this is the other. So this should be instead of plus, right, if I'm not mistaken, like this, and the first part should be just like times the number of columns. Let's see. So this is the, so this one, which one was this one? Top left to bottom right. Okay, just drink a little bit of water. Now my monitor went off. Give me just a second to try to turn it on. Hope it didn't break. Oh, no signal. Why? Ah, okay. Now it's. I don't know what happened. Now it's back. Let's see. So let's see. This is top left to bottom right. Okay. So we want to go +1 +1. The change row plus the offset minus. Yeah, and I have to be careful about the offset. Change column plus offset minus check. So basically the column part should be this part that is column wise should be like this one. For the X, and the other part should go like this one. So change col plus offset minus check. So I believe, if I'm not mistaken, just let me try this quickly. Are these the same? And I have these additional square brackets here, which I don't want. So yeah, this is the same for the right part, and for the left part, where is it? Now I'm blind. Where is this diagonal? This one. So let's try to do this one for here. Like this. Okay. Let's see if this is going to do the trick. Winner is all. Yeah, perfect. And then there is only one left. Let me see what you guys wrote. What was the last thing that I read? In diagonals, you can easily see the colors. Yeah, this is what I read. Then the next message, you can just take the parentheses and convert them to square brackets, the calls. Let's see what Leor says. Enjoy rest of stream. Sensei going back to code myself. Yeah, happy coding. Happy coding. Bye bye. See you soon. I believe I will see you on Sunday. Okay, so this is the last diagonal standing still. And I want to do this part here as well in such way that we will test that diagonal. So I will just copy paste just to make this quicker, because I'm already streaming too long. I will copy paste this as a text here, just to see visually. So what I can do, this is the same, so I can do 0, 1, 2, 3. So x, then I can do the second one here, so it's going to be 1 for the x. Then the O can go 0, doesn't matter. Then I need to build this one. So here I will need a third one. No, actually it's better, smarter to use this one here. So then this 0 can be 2, right? So that I have O here. So let me just draw what I have so far. X, O, X, O. This is for the first two, then 1, 2. So X, O. And then I will need still here, so I can do the X here. So that will be 3 for the X. Then for the O, I can make it here, that we already have the O helper here. Then X can be 2, right? 2 for the X, so that we have 1 here. Now O doesn't matter, 6 for example. And then finally 3 for the X. This should be the winning one. So 0, 1, 2, 3. 0, 1, 2, 3, 1, 2, 3, 3, 2, 6, 3. 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, 3, 2, 6, 3. So 6, 3 is already here. Okay, then the code change, which is the most important part. And I will copy paste this code just in case, because I've done so many things so that I don't lose the code by some accident, because something happened with my monitor, it turned off, so it can happen with my computer as well. No, actually I have battery, but anyways, maybe the website can go crazy. Give me just a second to save this. You don't see this is a different screen, but I will do it as quickly as possible, just to go into the directory where I have this. And let's call this, for example, for in L2. Paste there. Okay, we can Now continue, and let me see what you guys say. You might notice the board access is the same always. It changes its change. Yeah. Since the most logic is actually in the if. Yeah. So this is the most important part. So let's see here, which was the second diagonal here. This is where we left off. So basically, this part here should be a square bracket. This one we already have as a square bracket. And then here, not like this, but I don't need 2 times to multiply with calls and just do this part, I believe. And let's run and see how this works. Yeah, nice. Cool. So we have the detection of the winner. For the tie, it's going to be extremely hard to do it on this size, so maybe I will shrink it down and make a tie just to see if that works. Then that would basically be the end of the today's session, this second part. How long am I already in stream? Almost 2 hours. Okay, let's try just to see if the tie works. If it works perfect, I will end here. If not, I will see if there is an easy fix to solve it. So we want to change these into, I will just leave this for as a reference. So let's say 4, 4. And now I want to make something like 0, 1, 2, 3. That's okay. Then let's do 0, 1, 2, 3 again. Then let's do 0, 1, 2, 3. 1. I didn't have 0. I'm 0. 0, 1, 2, 3. And then just the opposite. Let's say 3, 2, 1, 0. Let's see if this is going to be a tie. It's a tie. Oh, okay, perfect. Good news. I was worried, not because I'm not having fun, but because I already am streaming for 2 hours and I wouldn't like to see some code breaking feature now that will take half an hour to solve and then make this video long. I mean, it's already long, but longer. Perfect. So this is so cool. I will not play because, like I said, I have already 2 hours into this video. So I would here play with the size of the board, try to see, and also the size of the winner, like the sequence, the winning sequence length, so that I test maybe, I don't know, 12 by 10, and if there is 5 of this. But let's just like leave it as it is for now. I'm going to do this again anyways very soon. When I learn a bit more about Zig, and I will try to make the part 3, maybe run this as a WebAssembly module in browser or something like that, so to make this interesting. Or maybe the first thing, yeah, I mentioned, yeah, so I will not do that. I will probably then first do not the WebAssembly part, but I will maybe do the file system integration so that we can save, let's say, the state of the board, the history. So I'm not still using the history. I just created this history, but because this took so much time, I'm not going to actually use history in this version. So I'm going to wrap it up here. But in the next version, when I start using the file system, then it makes sense that I actually finish the history, that I actually, when there is a move being decided here, move being made, that I also not only check for the winner, that I also update the history, and that can be saved immediately on the file, for example, something like that, so that I play with working with files, and of course to play with the user input instead of these. And it's going to be easier to manually test things. So instead of this, that I type like I want to play first colon, second colon, press enter, and then we see the update. So that's, I guess, is the plan for the next version of N-inline. So adding the file system support and interaction with the user, or both. I will need to install manually, not manually, or I want to say natively. And that's the plan for the next version. And then maybe the fourth version, I can then integrate something. I can do WebAssembly in the browser. And then, so why I would prefer doing this file system version first, because it's still going to be only Zig. It's going to be focused on Zig, and it's going to be running locally. And again, one more thing to play with, to run it locally and run it maybe in different regimes, like passing maybe the moves as the arguments or something like that. So I will see that I maybe have even 2 streams about running it locally that will do different things. And then the next part with the WebAssembly, if I want to show something in the browser, it has to be JavaScript. So I will have to combine with JavaScript. So that's why I'm going to leave it as the end. At the end, because I want to focus more on Zig, and I do have some JavaScript experience on my work and privately before. It's not my primary language, but I'm comfortable with it enough so that I can do something like this. And I did play before with WebAssembly and JavaScript, but with Rust compiled into WebAssembly, not with Zig. And what I've seen so far, they even simplified. So when I did it, it was like a bit more of boilerplate code to make JavaScript connect to the WebAssembly. Now it's easier. I haven't tried it in years. So that's why I'm going to leave this as the last part of this N-inline. So once I play with the local install Zig and save games in files and load them from files and interact with the user with the keyboard, then I will do the version that will run in the browser. And then who knows, maybe after I finish that part, maybe we can combine. Maybe I can run this as a backend, like adapt it a little bit, because then you will not type directly to Zig. You will maybe receive something from JavaScript, send it to server, then it receives, the Zig backend receives it, saves the games and everything there, and then you just, like by the click of the button in the browser, you make server that runs Zig, send something to the browser that will then be actually deployed as a WebAssembly, and so on. So this is an interesting project. It will take some time to do all these things, but like I said, first thing first, the next time I will do it, I will just do the local machine Zig playground with this game. So just save things to files, load games, save games, interact with users. So that's the plan for the next time. And the next time I will do it, I don't know, maybe immediately after 30 days pass, if I don't start another project. But I think this is interesting, so maybe it makes sense that I do it after. So at least this is the working version. So there is one version of the game that works, and then after 30 days I can upgrade it so that it can run locally and interact with users, save states. Okay, that is the plan. So I will be streaming today the regular 27th, I believe, day of Zig coding challenge. Thanks guys for help a lot. Let me see what you wrote. Robert says, don't you run in the browser already? Yeah, I run it. Yes, that's true. But as a WebAssembly, I want to do WebAssembly. That will be interesting. Thanks, Robert. You've been a lot of help today. And see you guys later, maybe even today. I mean, I will be today for sure, streaming later. That's the plan. So hopefully I will see a lot of you guys later today. Let me go here and say officially bye-bye from this screen. Bye-bye. See you later.